All right, so we'll start again here because I forgot that I had that. So let's get rid of this, and we will start from where we left off. Okay. So last class we started talking about comparative and absolute advantages, thinking about it kind of in the context of different countries. So I think we went through the definition of this idea of thinking about the CEO and the mechanic, and who could fix the car in less time, but also someone's time was more valuable, so maybe that they could have an absolute advantage, not a comparative advantage. So we'll dive into that a little bit more today. We kind of had this set up as this is going to be a problem the whole semester. So we had this set up as two different countries. They were had the option of producing two different goods. So we're really boiling this down, simplifying this. But if we can understand kind of a more simplified version, we could extend this to a more complicated version, and the same principles would apply. So here I just said large and small jets. You kind of look at old textbooks like there's always kind of guns and butter to economy. You had economy, you could either produce something to fight or something to feed your people, and there was a trade-off between the two. Right? So same kind of idea here. We're just thinking about if we took all of our resources for jet production, we could either use all those resources towards small, or we could use all those resources towards large jets, or a combination of the two, right? So this table is showing us if Brazil uses all the resources to produce large jets, they can only produce 10. If they're using all their resources to produce small jets, produce 30. Okay? So we said for the absolute advantage, it's pretty easy to identify, right? Because I look at this and I said, well, if someone, the country used all the resources, who could produce more large jets? 30 is greater than 10, so the United States has an absolute advantage, right, in large jet production. If they're using all their resources, who can produce more small jets? Well, 40 is greater than 30, so the United States also has an absolute advantage in small jet production, right? So when it comes to having an absolute advantage, the United States has an advantage in production of both of these. When it comes to comparative advantage, you can only have a comparative advantage in one of these two goods, right? And we'll kind of see why here in a second. So having the comparative advantage means when you produce that good, you can do it at a lower cost than the other person, or in this case, the other country. Okay? So what is the cost of each one of these goods? Well, think about it this way. If I started out and I was only producing large jets and I was in the United States, I would be producing 30. If I then want to take some of my resources and produce my first small jet, well, I'm going to have to reduce my production of large jets from 30 down to something that's left below that. So that idea is that to produce one good, there's a trade-off as I have to stop producing the other. Right? So how can I determine the cost? So the way we're going to do this is starting to think about production possibility curves, or sometimes these will be called production possibility frontiers, right? And they're going to help us come up with what the cost of production for these goods are. Right? So it's basically showing kind of the trade-off between producing these two goods. What could be for an individual, a firm, or in our case, kind of an entire country's economy. So represents the trade-off between two goods. And this is what we're going to do. Right? So I'm going to leave this up here in the slides, but I'm going to kind of show you how it was created. Right? So we go back and we think about, we've got two goods. So I think to make sure I'm lining this up, we've got small jets, we're going to put on the x-axis, and large jets, we're going to put on the y-axis. So all we're going to do in these initial examples are if I'm using all of my resources as the United States, and actually I'm going to do Brazil. I think that one might be a little bit easier to hammer this point on. If they're only producing small jets, and we went back to that little 4x4 table, it told us that they could only produce 30. They were using all their resources. That's the most small jets that Brazil could produce. If they were using all of their resources to produce large jets, they could only produce 10. So that's kind of where these points are coming from when we're graphing Brazil's production possibility curve. So if I start out at a point where I'm only producing large jets, and I want to start producing some small jets, I'm going to have to, in order to produce more small jets, start to decrease my production of large jets, right? Because I'm transitioning my resources from large to small jet production. So one thing we can think about is, what is the slope of this line, right? So if we're trying to calculate slope, kind of doing a pretty basic, but right, rise over run, or you can kind of think about this as kind of the change in y over the change in our x good. Right? Well, here our y good is large jet. So if I just think about the slope of this line, I could just use these two starting points. The change in y is going from 10 to 0, right? So it's falling by 10 there. The x value is going up from 0 to 30, right? Kind of the change in my y over the change in my x, this is going to give me kind of the slope of this line. Now, this is technically negative, right? So it's going from 10 to 0. So the change there was going down by 10. But when you draw this out, you're always going to have kind of this downward sloping line. So even if you forgot the kind of a negative sign there, you just did 10 over 30. Oh, well, I've got a downward sloping line. That slope is negative 1/3, right? Or negative 10 over 30. Questions on that before we keep moving? There's some other ways to think about this too. So if I'm looking at the United States here, what would the slope of their production possibilities curve be? So if I look at where does their large jet production start? 3, 4, 30. Yeah, right. So I would just do rise over run, or the change in y over the change in x. So my y value in the United States is going to go from 30 to 0, right? It fell from 30 to 0. So that change in my y would be what? Negative 30 in the United States. But their small jet production is going to go from 0 up to 40. All right. So negative 30 over 40. So we kind of think about it here as, and I'll get out of the way in just a second. Kind of the cost of a small jet here was right. What we're really saying was that if I want to produce one more small jet, that's going to cost me, the slope of that line tells me the cost of the x-axis good. So when I come up with a slope of that production possibilities curve, it's really telling me the cost of producing one more of the x-axis goods, right?
So basically, in Brazil's case, to make a small jet, it's 1/3 of the cost.
Yep.
Yes.
Yep. And so it's when I say it's 1/3, right? To get one more small jet, I'd have to forego producing 1/3 of a large jet, right? Right. That's how many resources I have to take away from large jet production to produce one small jet. Right? So that slope is the cost of one more of those x-axis goods. But that's always going to be in it's not in dollars, right? Because it's what I'm giving up. I'm not giving up money. I'm giving up producing the other good. That's my cost, right? So the cost is 1/3 of whatever I'm giving up, which is large jet production. Another way to think about this is like the real technical, this is the math way to think about this, calculating the slope of the line. There's two other ways you can think about this. One, if I can produce either 30 small jets using all my resources or just 10 large jets, what that's basically saying is that, well, for every 3 small jets, I can only produce 1 large jet, right? Or to produce 1 large jet, I'd have to give up producing 3 small jets, right? It's another way to think about it. I think another way that kind of, I guess, makes sense to me, and you don't even have to have the graph. So if you go back to this original little table here, that's how I always want people to think about it. So we've got US, Brazil, large, small. Just read. Just put the same numbers and everything up there. Yeah. So another way to think about this is, if I want the cost of one of these goods, so I can graph it out, right? Draw my production possibilities curve, come up with the cost, right? Calculate the slope. The slope is going to be the cost of that x-axis good. Or I could look at this table and say, okay, what's the cost to the US and Brazil producing one more small jet? I'll go to what I want to know the cost of. So the US's cost of a small jet. I will want to turn this into 1 unit because I want to know the cost of producing one more small jet. So how could I turn 40 into the value of 1? Divide anything by itself is always 1. So I'm just going to turn this into 1 unit. Now, if I divide the other good by that same value, right? Essentially, this is going to be the cost to the US of producing one more small jet. Sure enough, that lines up with what we did if we did rise over run, right? I can do the same thing for Brazil. What if I wanted to know Brazil's cost of one more small jet? I know if they want to produce 30 small jets, they got to give up 10 large jets. But I want the cost in terms of one more unit. How do I turn 30 into 1? Divide that by 30, divide this by 30. Sure enough, now to get one more small jet, the cost is a third of a large jet. And that lines up with the same thing as if I were to calculate it using the slope of that production possibilities curve.
Okay, over here, where do you get a -10, -30?
Right? So we're going from 10, if we're going between these 2 points, we're going from 10 down to 0. Right? Because here, this point represents, you want to think about it, 10, 0. Over here, this point is 0, 30. Right? Or I guess I'm writing this in terms of X and Y. I can technically have said. My Y value is going from 10 to 0, so that's -10, falling by 10. My X value is going from 0 to 30, going up by 30. So that's kind of where that -10 and that 30 comes from. Kind of cheat code here too, when doing these production possibilities curves, at least with the really simple ones, you're really just taking however much they can produce of the Y good, dividing it by however much they can produce of the X good, right? I mean, that's kind of a shortcut for that doesn't quite apply when we kind of complicate this, but at least with these basic models, we can also think about it that way. So all just different ways of thinking about the same thing. So I'll do this one more time and start out with the original table that we have up there. So I just showed you that you could come up with what the cost of a small jet was, and that lined up with what we did. We kind of graphed it and calculated the slope. Well, what if I want to know the cost of a large jet? So the cost here of a large jet, how do I turn 30 into 1? Divide it by 30. Means I should divide this by 30. The cost of one large jet is 4/3 of a small jet for the United States. And then for Brazil, how do I turn this large jet value into 1? Divide it by itself. To get one more large jet, Brazil has to give up 3 small jets. So I can calculate the cost of either one of these goods. Now, if I wanted to do it visually, I'd have to like flip the axes, right? To get the cost of my x-axis good, that's what the slope represented. I'd have to flip everything in order to determine what the cost of my large jets were. I'd have to put them on the x-axis. So this way is a little bit easier, I think, in terms of, you can kind of go work either way, calculate the cost of a large jet for a country or a small jet. Another thing that ends up being true, where do I want to? So we had cost of small jets here before, and I just told you the cost of large jets. So for Brazil, the cost of a large jet was what? 3 small jets, right? So what was the cost of the United States to produce one more? 4/3. Okay, so we had to give up 4/3 of a small jet here. So what do you notice about these numbers?
US give up more for a large jet.
So that's true.
It's reciprocal.
Yeah, so in case you don't remember this terminology, I don't know how long ago you had a math course, right? Basically, the costs are going to be reciprocal to each other, which means it's just 1 over the cost of the other goods. So notice here, if I took 3 I took 3 and did 1/3, right, 1 over that cost, it gives me the cost of the other good. If I do 1 over 4/3, that actually gives me 3/4, right? Basically, you're just flipping the numerators and the denominators. And so if I found the cost of small jet productions was 1/3 and 3/4, automatically I know the cost of large jet production would just be 3 over 1 and 4 over 3, right? Now, you don't have to think about it that way. You can go through and determine each cost individually, but once you have the cost to each country of one of these goods, you automatically know the cost of the other good is just the reciprocal, or flip the numerator and the denominator. Is that clear there? Any questions on that? Okay. It's not like a prerequisite that you would know that term coming in, so I'm just making sure that we're all on the same page. So here, we could do the absolute advantage very easily, right? Just by looking at that table, we said the US has absolute advantage in both goods. Who has the comparative advantage? So depends, right? On what good am I talking about, right? So who has the comparative advantage in small jet production? Their cost is lower, right? 1/3 of a large jet is a lot less than 3/4 of a large jet. So whoever has the lower cost has the comparative advantage. So Brazil actually has the comparative advantage in small jet production. They're not very good at producing large jets, so it's less costly for them when they choose instead to produce small jets. Who has the comparative advantage in large jet production? Well, the lower cost is 4/3 of a small jet as opposed to 3. So the US has a lower cost, they would have a comparative advantage in large jet production. Okay, so what always ends up being true, and you could like do the mathematical proof, and because these are reciprocals, you can only ever have a comparative advantage in one good, right? Because you want to think about it this way, if 3 is, so I'll do the other way. So if 4 is greater than 2, right? When I flip those numerators and those denominators, or 1 over 2 and 1 over 4, it's always going to be that larger number, 1 over that, is going to be a smaller value, right? Now you can work through the mathematical proof, or you could just write down and remember, you can only have a comparative advantage in one of these goods, right? And if you have a comparative advantage in small jet production, as Brazil does, then they're not going to have the comparative advantage in large jet production. The other country, the US in this case, would have the comparative advantage in that other country. Okay. Like I said, if you want to play around with some sample numbers, do the reciprocals, you can kind of prove to yourself that you can only ever have kind of the lower cost in one of those goods. Any questions on this idea before we keep pushing forward here? Okay, so I'll show you another example, just some different numbers, different goods, different way to think about this. And then I'll kind of push it a little bit further. So let's say, this I think maybe shows some of behind the scenes. So let's say you could produce what? Computers or produce, right? You can build technology or your agriculture sector. And you've only got a certain number of labor hours, right? You've only got a certain number of people in your economy. They work, I don't know, 40-hour work weeks or whatever. You've got a total of 50,000 labor hours that you can either put towards technology, producing computers. I'm simplifying this with one good, but you can even imagine like these are just the resources you put into those sectors, right? So it could be a variety of technology goods. Here, I'm just going to use one to make it a little bit easier to talk about. So you can either put that labor towards producing computers, or you put them out producing some food, right, or produce, things to feed the people. So let's think about if every single computer required 100 labor hours, and every single ton of wheat required 10. Right. Well, then I can kind of see like, it takes a lot more of my labor hours to produce computers. I'm probably going to be able to produce fewer computers if I used all my resources than if I was only producing wheat, all right, or whatever kind of produce good I choose. So we can just start to play around with this. If I put all of my kind of labor hours, right, into computers, right, 50,000 labor hours. Well, if I divide that by 100, right, because for every 100 labor hours, I'm going to get one computer, then I can produce 500 computers there with all my labor hour resources. I'm not going to have to necessarily convert something like that. You can kind of think about, right, I've got these labor hours, it takes 100 of them to produce one computer. So how many computers can I get? 50,000 divided by 100,
at 500. Now I put 0 labor hours in the producing wheat, so I get 0 bushels or tons or however we're measuring the, the sweet production. I'm getting 0 of that. I then can start thinking about I can move between the 2 points, right? Now I can think about the other extreme. If I put all of my labor hours into wheat production, well, for every 10 hours, I get 1 bushel or a ton of wheat, right? Whatever, how we're measuring this. So I divide this by 10, I'd end up with, I can get 5,000 units of wheat. If I'm only producing wheat, if I put 0 labor hours in computer production, I'll get 0 computers back. And then there's just a trade-off between the two, right? So maybe I want to put equal number of labor hours into each. So these 2,500 hours of labor will get me what? Divide that by 100, 250 computers. Well, that same number of labor hours put towards wheat will give me 2,500 units of wheat. That's what a pricing comes in. So we haven't even talked about the pricing yet, but we can come up with it here, right? So in these examples, I've kept everything linear, right? So linear means that it's a straight line. There's no like change in the slope. And that's what I'll do in these examples. So if we wanted to, we could just use those 2 extreme points to kind of give ourselves a nice visualization of this production possibilities curve, right? So I think about wheat on my x-axis and computers on my y-axis here. What point am I going to be at if I'm only producing computers? I can get 500 of them, but then I would have 0 bushels or whatever of wheat. What if I was only producing wheat? You could get what? 5,000 of them, right? But in doing that, I now get 0 computers. Well, I said I'm keeping everything linear in these examples. So really, as I move between the two, I can start to take some of my labor hours, put it towards wheat, right? Take it away from computers. I then start getting more bushels of wheat, but fewer amount of computers when I do that. I kind of think about I can graph each one of these points, but really it's a nice continuous line. I can put whatever combination of labor hours towards computer media that I want, right? I'd be somewhere on that line. Right? So how would I come up with the cost of 1 additional bushel of wheat here? I said before, rise over run, or you think about the change in our x value divided by the change in our, sorry, y value divided by the change in our x value.
It'd be negative 500 over 5,000, right?
Yeah, so we're going to go to the change in y. We're going from 500 to 0. So negative 500. What's our change in x? Well, we're going from 0 to 5,000. So I'm looking at this right, negative 110. Questions? So the cost of our x-axis good, 1 more bushel of wheat, is we have to give up 1/10 of a computer. So that slope is always negative, so that kind of reflects like this is a cost, right? There's always a trade-off, right? So to get 1 more bushel of wheat, I'd have to give up whatever that slope was, or 1/10 of a computer. Okay? Any other questions on that? So what would be the cost of 1 computer? Yeah, right. We said if I can get the cost of the x-axis good by finding the slope, right? The cost of my y-axis good is always the reciprocal, right? So if the cost of my x-axis good is 1/10, to get 1 more computer, 10 over 1, or 10 bushels of wheat will be the cost of getting 1 more computer, right? The cost of that other good, the y-axis good, is just the reciprocal of the cost that we calculated for the x-axis good, or just split the numerator and the denominator. Okay, so we determine these costs. Well, pretty good time. So, I kind of I left this slide blank. I was drawing that out for you, showing you how to take the data, put it into a nice visualization. So hopefully when I'm doing things on the board, I said those are the things you should be taking notes on. If the slide is blank, it will remain blank. The completed slide because I did the work on the board. Right, just kind of a way for me to kind of prompt you. This is where we're gonna do some work on the board here. So we determined all this already. I think this is, I guess, written out a little more technical, right? But the cost of the x-axis good. It's always just whatever your slope is, and then 1 over that slope, or flipping the numerator to the denominator, would be the cost of your y-axis good. And we talked about, we determine those costs, and it is up on the board. This is kind of a nice little summary slide here. Okay. So in practice, I'll show you what some kind of sample items are going to look like, and then I'll go to the next one. So I won't use them today, but on Monday, I'll start using these items for points. In fact, we're going to go through these questions, and hopefully, right, they're going to help you. Because after the class, I'm going to put up an online quiz that I expect to be done before we start class on Monday. So 11:59 a.m. That's before we start class on Monday. Okay, so I'll show up as soon as we're done with class on campus. Okay? It's going to have 3 questions. You just go on and do it. You get all the questions wrong. Well, sorry, there's 4 questions. The first question is click earn base points to earn the 7 out of 10 base points for the day, right? And then the other 3 questions are you get a point for answering equal and correct. There's no time limit, right? Look through your notes. I want you to get these points. They're very similar to these, right? So let's say I gave you this production probabilities curve, and I likely won't give you a curve on those questions. I'll just give you the numbers, kind of like not here, kind of like I did here, right? And then you kind of use those numbers for each subsequent problem. Okay, so you've got, I think the example I gave you, I'll give you 2 people instead of 2 countries, and then they'll be producing 2 different goods, not large and small jets, but I believe it's like gallons of milk and ground beef, pounds of ground beef. Maybe look at that. But anyway, so question might look something like this, right? If I'm looking at this economy, who produces, or producing 200 units of butter, how many guns we produce, right? This is going to be pushing a little bit further than what we've done up to this point. Now we're thinking about, I don't want the cost of goods. I'm thinking about, how do I get to other points along this production possibilities curve? Right? So if I want to be the point where I'm at 200 units of butter, how many guns can I produce? Well, butter's on my x-axis, guns on my y-axis. I go right here. 200 units of butter production means that I would only be able to produce 300 guns, right? The classic guns of butter. So I could also kind of say, like, I don't know, what if I wanted to produce 600 units of butter? Well, I'd be at this point on the curve at 600 units of butter. I can only produce 100 guns. Yeah.
Is there a way to do that without the graph?
Yeah, but I'm not going to push you guys to do that.
Without the graph, and I got 400.
So you could do y is equal to, right? You have your intercept, so 400 minus what? 800 over 400, so minus 2. No. 1/2. Right? You can plug different values in there. I may have, if you plug in 300 here, you get what, 150. Maybe the values I have over here should be right. But yeah, I'm not going to push you to kind of use the formulas. If I ever asked you, I would give you a graph where you could just kind of find the coordinates. Yep. So what if I want to do the opportunity cost of 1 more unit of butter? All right. Well, we've talked about this. I got to calculate what? If I want the cost of 1 more unit of the X good, it's just a slope. All right. So what's the slope? Right? The change in the rise, change in the run, or change in Y over change in X. Y is going to go from 400 to 0. Right? X is going to go from 0 to 800. So 400 over 800, we should have a kind of negative, or sorry, negative 400 over 800. We should have a negative 1/2 there as our slope. So half a unit of whatever the other good was. So to produce 1 more unit of my x-axis good butter, I have to give up a half a unit of my other good, which is on the y-axis, which is half a gun. Right? So that's where our answer comes from. Seems trivial, but this is like go back. Kind of a good book. I've tried. could not admit to this as an economist, but I should have read it all the way through. It's a hard book to get through, although it's very interesting. Book by Adam Smith. If you go back and read some of his kind of works, he starts out a lot of his examples thinking about his guns and butter, because at the time, like, you're thinking about an economy, especially at that point in time, you really were. It's this delicate balance of defense and protecting yourself while also taking your resources and being able to, like, make sure your people aren't starving and then want to revolt, right? So this is kind of why we start out with this gun and butter example, because it's kind of like the trade-off for a country between keeping its citizens safe, but also making sure that it's providing them with enough resources to be happy, right, while we're all in the. So what was the opportunity cost? So we had the opportunity cost, or the cost of 1 unit of butter was half a gun. So that came out of 400 over 800, or 1/2, right? So what would the cost of my y-axis good gun be? Should just be the reciprocal, right? 1 over 1/2, or flip the numerator and the denominator. Should be 2 units, right? Of butter there. Sure enough, that's what we end up getting. If you wanted to, you could like flip the x and y axis and then like do the rise over run and basically prove to yourself that it's always going to be that reciprocal. Okay. Any questions on that? No? So, you know, our usual class, I open these up and give you a little bit of time to work through them. Generally, I'll work through an example first and then ask you a very similar question, just kind of when setting up this in class, and then ask you the questions on the online quiz instead. Now the online quiz will kind of push you to think about, you might have to graph them yourself, right? But to think about these production possibilities curves, but then we'll go one step further, which is asking then who has an absolute and who has comparative advantage. Right? So it's kind of combining these skills, being able to draw, understand these production possibilities curves, and then use those costs to make statements about comparative advantage. The absolute advantage is easy, right? You can just look at the original starting numbers, who can produce the most. Okay. Questions? We keep moving here. Yeah.
Did you say that was on the quiz?
Yeah. So those will.
On the 27th?
Nope. So it'll be due before we start class on Monday. So that's what, the 29th. It shouldn't be up there yet. Yeah. Okay. So let me clarify. So on the Connect on the My Econ Lab homework platform, there's the first homework assignment, which is, I forget the exact date, it's down the road, 9th of September. The other two are just like getting used. They're not for any points. It's just if you want to play around with them, it kind of gets you used to kind of how you're going to use that. The first, I think, 5 questions in the first homework assignment, I actually stole some of what I thought were the most important questions in that getting started assignment. But those are just there if you want to get familiarized kind of with the program. The only one that's worth points is that one that says homework number 1. Yep. And then the online quiz for today, that won't show up until I think I have it set to be 1 o'clock. So after we're out of this class. Okay.
Oh.
Yep.
And it'll show up on Canvas.
It'll show up on Canvas. Yep. It'll be under the assignments tab. It'll be under the quizzes tab, but it will pop up. I have for me, maybe people have different preferences. You can set the homepage on Canvas to be anything. I set it to be the assignments because like that's what's the most pertinent, like knowing when the due dates are, being able to see what is currently out there. And I try to organize them in a way you can always kind of see what the current ones are. Right now, everything up there is current. But as we kind of have due dates go past, I'll then move them to other categories, and whatever's at the top will be what are open assignments, right? Assignments that haven't been due yet. Someone else had it.
Yeah. How long is the quiz? Like till like 12 tonight?
No, so you can get on anytime today, tomorrow, or Sunday,
Oh.
or Monday morning before 11:59 a.m. before we start class at 12. Yep. Any other questions, clarifications on anything with homework or? They're good questions. Always feel free to, if you need clarification on something, ask me. Okay? I'm going to skip ahead here. We kind of already went through a lot of this, so this is just going to be what we worked through. I did things a little bit different order than I had originally planned. So this is just kind of a good summary slide for what the work that we did in the board. It'll be nice to have that, but I wanted to go here. All right. So this is a nice kind of summary visualization. I want to walk through where this comes from. Right? So we have a really simplistic kind of economies that we were looking at before, where we had 2 goods, but we only had one country producing this. Right? Maybe I think of something like different states within the United States have different comparative advantages. We'll make it a little more complicated, but still simple. Every state can only produce 2 goods, right? Once again, it doesn't matter if it's a specific good, we think about they can produce goods in 2 different sectors, right? 2 different main sectors. So if I've got 50 states, who do I want, whatever my x-axis, let's say it's, I don't know, computers and automobiles, right? So I've got kind of more of this older kind of production of automobiles, and I want to progress my society towards producing more computers or technology. So I'm going to start giving up some of that automobile production to produce kind of higher technology goods like that. So as I start to produce computers on this x-axis, and I'm going to start from a point where all of my states were only producing automobiles, right? Who am I going to want? What state am I going to want to start producing computers first? The one that can do it at the lowest cost, right? Whoever can do it the cheapest, right? Whoever is going to give up fewer automobile production, fewer automobiles to produce computers, that's the state I want to produce computers first. So they're going to have the lowest cost. So if I'm thinking about slopes, as my costs get closer and closer to 0, what does that slope look more and more like? Horizontal line, right? Right. So the flatter the curve, that means the lower the slope or the lower the cost, right? Because the slope is the cost of my x-axis good. So the very first state, their production possibilities curve is going to look something like this. And they'll give up their automobile production until they've used all their resources. And now that one state, right? And we're thinking about the United States economy, but we're looking at one specific state. Once they've taken all their resources to produce computers and they've given up all their automobile production, well, now, if I want to get more computers, what do I have to do? Well, that state, they ran out of their labor hours. So I've got to go to the next state, or the state that can do it at the next lowest cost, right? Well, I know the second state, they didn't have the lowest cost, they had the second lowest. So their slope is going to be not quite as flat, right? As that cost grows, as the slope goes up, you're getting a steeper and steeper curve. So maybe the next state looks something like this. Then I have to go to the next state. These costs start getting higher and higher. And then I kind of continue to do that all the way until I have every single state producing computers. And once I get to those last states, the ones that could do it, but it was really costly, I'm going to get these really, really steep slopes on my production possibilities curve. So notice here, I kind of have it like segmented, only in 3 there. You can kind of imagine you could do this for all 50 states, right? And as you include not just states, but maybe I want to break this down person by person, I'm going to get this really nice, smooth kind of curvature in my production possibilities curve or my production possibilities frontier. Those 2 terms are interchangeable. Okay. Does that idea make sense? And so I won't push you this far in this class, but you can kind of think about, if I had this nice smooth line, I could start to do some derivatives and calculus and figure out exactly what my cost was, but, depending on how many units of that x-axis good I wanted to produce. I won't push you that far. At the very least, I might give you something like this, where you've got like 2 or 3 people, and your cost just kind of changes as you kind of progress from person 1 producing the good to person 2 to person 3 producing the good. We're just kind of giving you a glimpse into like what could be possible. Any questions at this point? Where are we at on time? Yeah, 10 minutes. All right. So, we'll talk about a couple traits of these production possibilities curves or frontiers. We won't get there today, but on Monday, we will kind of take these comparative advantages and to kind of wrap up this idea. We'll think about gains to trade, which is kind of a cool thing to take a look at. That sometimes like not producing a good, you actually end up with more that if you then are able to trade with people. So when we look at these production possibilities curves, We want to think about it like the following. So let's say I did have, doesn't even matter, just two goods, right? You really need goods, use the computers, automobiles example again as your X and your Y good. Any point on this curve represents what? Well, remember what we were doing was saying, if I want to start producing more computers and give up automobiles, right? That's assuming that we're using all of our resources and then converting some of those resources to producing another good. So we're still using all of our resources. So any point on that line is some combination of this X and Y good, right? Or automobiles and computers. It's some combination such that we're using all our resources. So we kind of call those, any point along that curve efficient points. We're using all of our resources, right? No resources are laying around going to waste. Okay. The easiest way to think about it is, well, what if I'm at a point that's underneath that curve or underneath that frontier? Well, what am I doing then? Well, think about here. Let's say I was producing as much of this Y good or as many automobiles as I possibly could with all my resources. If instead I was producing somewhere down here, right? What am I now doing? Well, I haven't produced any more of the X good or any more computers. I just produced less of the Y good. I'm not using all of my resources. Any point in here, we would kind of call inefficient, right? Any point underneath the curve is inefficient. Any point on the curve, we would say is efficient. Okay. So I don't know if I can draw like an arrow here, right? If we're on that production possibilities curve, we're at an efficient point. We're using all of our resources, right? Now, what if I was at a point out here? Can I get to that point? Well, I tried to draw this, but it's like, well, I was using all my resources to produce this many of the Y good. If I wanted to produce at that same point, but now I'm producing part of the X good as well, I need more resources, right? I was already using them all here, right? So to keep producing the same amount of that Y good, but also produce some of the X good, I'm going to need more resources.
This may not be right, but
Mhm.
we also have to be that same, the same, like, because you said it's like one country, for example, it's one
Mhm.
country and then it slopes down because it's another. Would you have to use that same first country to keep it at that same point? Does that make sense?
So you're
Because
saying,
they have the highest production.
I see what you're
value.
saying. So it doesn't matter, right?
Okay.
In the sense that at this point, every single person, state, however you want to break it down, everyone in the economy is only producing the Y good. So if I want to keep producing that same level of that Y good, but also get some of the X good, I need more people,
Okay.
right? Like if I've already used them all up to produce this level, like I tried to draw this on the same line. It might be a little bit slowed down, but it's supposed to be.
I get you.
But yeah, so basically any point past this line or outside of my frontier, we would kind of call these, I don't know if this is, I'm terrible at spelling, you'll figure out by the way, it's not feasible, right? We don't have enough resources to get to a point that's outside of my production possibilities curve or outside of my production possibilities frontier, right? So those are kind of our three things that we're interested in. Inefficient points, points that aren't feasible, and then being on that curve, those would be efficient points in our economy. We're using all of our resources to produce some combination of these two goods. Okay. And this is like all of me saying this, we kind of already talked about this law of increasing costs, right? I already drew that out visually for you. This is just the idea that the first person to produce that X good will be to do at the lowest cost, then I move to the next lowest, and so on and so forth, right? So as I produce more of that X good, my costs are going to have to increase, right? So I'm going to eventually have to move to the next person or the next state who can produce it. And in doing so, right, I chose the person to first start producing that X-axis good by choosing who did the lowest cost. So the next person I go to means their cost is going to be a little bit higher. Okay. Any questions on there? I think I might wrap it up here. So this is like a good clicker question. Just to kind of revisit this, but, I just walked through all these examples here. So which of these points are efficient? Yeah. Yeah, right, there's actually multiple answers. A and B are both on that production possibilities curve. We would say point D is what? Not feasible, we don't have enough resources. Point C, just barely, but a little inefficient, right? We're a little bit underneath that curve. Okay, so we'll pick up kind of where we left off here, wrap up our discussion about production possibilities curves, and then think about gains of trade. Now, I'll leave you with this one thing before I let you get out of here. And then I won't have to do this week. So I accidentally skipped over this slide earlier in the week. I think I was supposed to do it Monday. So positive and normative statements. Positive statements are what people actually do. When we look at the data, do people actually save X amount of dollars? Right? Normative is what should people do. I might say, well, not looking at data, but I think people should have this much saved before they retire, right? So normative are facts or things that are actually have occurred. Normative are more like opinions, right? So you guys haven't seen this normative amount of economics, right? Oh yeah, that's just like your opinion. If you haven't seen the two of these, go to watch the Big Lebowski this weekend. It's hilarious. Other than that, make sure you get registered for the homework, register your iClicker, have a fun, safe weekend, and I will see you guys on Monday.